Basically, I am planning to introduce the solar energy system for the remote village school in northern province. It can be applicable anywhere as far as the technology is same. So when I am going to present this, maybe just for things, I will switch off the video to make it more clear to you in case if it is bandwidth is limited. So if I tell, I hope you are all are able to see my slides. So my presentation slides I have categorized into three. One is renewable energy potential. Basically, we wanted to motivate all of even the school children, to community, to business people, to everybody, because renewable energy is blessed to Sri Lanka, especially northern province, especially wind and solar. So just to give you some motivation, then some demonstrating plan we have installed in the Faculty of Engineering for those who wanted to come and learn more in depth. They are always welcome to us. Then the third part is introducing the solar energy for remote village schools. So that is the way I align up my presentation. Uh, so when I take it to the next slide, the first thing I will say, what are the potential renewable energy in the northern province? Especially I'm targeting northern province because when we look from the wind and solar, we are blessed with enormous wind, very good smooth wind. Even in the South Asian region, this Mannar area has a very smooth and strong wind. So that you might have heard that 100 megawatt wind power plant is already commissioned, and few more plants. That means another almost like 100 megawatt is going to come very soon. And also other one is in Kaudarimunai in Punagiri area, this flood, where again 250 megawatt of solar plus wind is being promoted. So the people around here will have enormous job opportunities if they are being trained or if they are being learned this kind of technology, at least in their day-to-day life, as well as some kind of in-depth in technical way. So the faculty, even the solar point of view, you can see the Jello is the most high solar radiance available in this country. So we are blessed with enormous solar power as well. That means, for example, if we get 1 kilowatt rated panels, then it will bring us about 100 units per month. So basically 1 kilowatt means you can put 4 panels with each with 250 watts, which is commonly available now. 300 watts also available. So with that one, you can create about 100 units per month. That is a range in the northern province at the moment. So just to tell you other one, from the government point of view or the CEB, Ceylon Electricity Board point of view, who are the major technical people who plan for the electricity demand and how to generate and everything, according to the Ceylon Electricity Board long-term plan, from 2020 onward, enormous solar and wind, the green is wind and yellow is solar, going to come up in their power generation plant. So we can see the future is going to be making more and more solar plants and wind power plants as per the CB long-term plan, because it is not a political move or anything. It is purely technical. More than 40 professional engineers do work for about 10 years to finalize this plan. So it's very professional way they did. So you can believe me, so much of wind and solar going to be integrated to the system, so that there's an enormous job opportunity. So, for example, even the CB long-term plan, when you look from the some portion of that one, of course, the Mannar northern areas are very much blessed with wind and solar power plants, solar power resources. So we got enormous resources in this area to be taken from the free resources, electricity to be taken from the free resources. Even very soon, we'll be getting about 250 megawatt wind power plant and 150 megawatt solar power plant in Punagiri, which is about 40 kilometers from our Kilnochi faculty. So these are in the plan. Plan mean it is going to happen definitely very soon. So that is what I'm just giving a motivation. And also, just to tell you, our university faculty of engineering, even though it is very young, very, very young, but we have contributed to the national planning, saying that the floating power solar power plant capacity of 42 kilowatt was installed at University of Jaffna in 2020, making the country first such project as a pilot project. So we have made the lead to the country to contribute to get their plan done based on our pilot project. We have proven that this solar power, especially floating solar, is going to give you more advantage, especially for the country like Sri Lanka, where we have enormous ponds and surrounded by the sea. So that has been done with the help of Norway government, and it has been implemented inside the faculty premises. There's a pond, and many people come and disseminate, take their knowledge from our dissemination. And that is one of the biggest contribution from the faculty to the national level, where we are competing with all leading universities. So just to summarize the motivational talk at the beginning of this discussion, we have excellent business opportunity, especially on the renewable energy projects, which is proven as economical viable project, and it is going to take up in the near future in the country. And excellent employment opportunity, especially in northern province, where we have a lot of shortage of employment at the moment. Even the arts faculty graduates or few other faculty graduates little bit struggling because they wanted to work in the northern province and we don't have much employment opportunities. But this is one of the opening because we have enormous resources. And also, of course, from this country, from the region, we can contribute and we can be proud that our economical growth will be partially made through this making the business out of the free resources available from the renewable energy, which will be also contribute to the country GDP in total. So that is where I thought my this motivational talk, even though when we target to the schools, rural schools to be powered with the solar, that is again one side. It is not only giving the power to the rural schools, but also giving an opportunity to disseminate this technology and the business opportunities for the rural area for those kind of students, because normally the business developers take risk, and the risk can be taken by mostly the people who are living with the nature. That is happening in most of the rural area people. So it will kick up some business opportunity in their brain as well. So let's see how the faculty can help in terms of disseminating knowledge on uh, demonstrating the renewable energy technologies. For example, we have installed 5 kilowatt grid connected wind turbine with the help of the wind force, which is the latest technology. So anybody wanted to get in depth of how the wind generating plant is working, we can help them always. So this is some photographs of the plant which was erected and rotating with the grid connected system. Secondly, of course, you might know at the time we collaborated with the University of Peradeniya and established first hybrid power plant in Sri Lanka in Eluvadiv Island. Eluvadiv Island is in closer to the northern area, where a couple of engineers who are even today presenting, including Amalendran, they worked on the ground, go around and did the sociology study, checking the civilians whether they like this or not, and finally end up with implementing the Eluvadivu with the first hybrid power plant in the country, which was opened by the Honorable Minister of Power and Energy in 2016. So this is just about 650-meter width and 3-kilometer length of the small island. And this is again a pilot project on islanded operation. That means not grid connected, without connecting to the grid, and it was operated separately as a wind power plus solar power plus diesel power plus battery. Altogether, it was operated. Of course, still we are studying on some more operational matters to be improved further. But this was one of the very successful when we implement, and this was the first hybrid plant in Sri Lanka. So you can see the island, Alvadiv Island, it was implemented. Now they are going to implement to all 3 islands. And you might have heard the tender is very highly competitive between creating a lot of political issues as well between India and China. But anyway, technically, this is very, very feasible project, and it can go ahead on implementing such technology by harvesting the free energy in the wind and solar. So the third pilot project we implemented at the Faculty of Engineering, where the rooftop, the top of the roof, we put solar, and it was inaugurated by the former Vice Chancellor. And it is working now, grid connected without any problem. That is again 55 kilowatt of string solar panels. That means all the panels are connected together and finally go through the converter. Other one is about 5 kilowatt that was placed in this area. Each and every individual panel connected to the individual converter, small micro converter, and connected to the grid. So the two technology we already placed here, and we were checking, and this is the output of the so that 55 kilowatt solar panel. That mean group of panels. So you can see sometime during the daytime when the cloud comes, it has some disturbance, but other than that, it is okay. As far as it is grid connected, there won't be any problem much on this one, because we have the high capacity transformer, 2000 kilowatt, that means 2 MVA transformer. So we are connecting only 50 kilowatt to that one. So it's negligible compared to 50 to 2000 ratio. Then this is the power generated during the day, every day, and it's for the month of October 2017. You can see roughly we are getting about 250 unit per day, 250 unit per day with the 55 kilowatt rooftop solar. So even I just wanted to give you a summary and get the average on, for example, for the whole year, we generated 81,830 kilowatt hour. Sorry, this should be kilowatt hour. So that much of, that means 81,830 units of energy was generated from the 55 kilowatts. Accordingly, when we average it for a month, it's come to about 31 units. So this for example, not only month, for example, one 250 watts panel, because we had made all of these 55 kilowatt based on the 250 watts several panels. So one 250 watts panels, if I put that one, that's going to generate me in average of 31 units monthly. So that is a electricity generation from 250 watts panel in average throughout the year. So but some month, you know, it will be less, some month it will be high. So in average, it comes to 31 units for 250 watts panel. So that is explained here. But we also have some other technology, other string converter and the micro converter, some other different month. Like for example, December is the lowest month, you know, more cloudy area. That time we got about 26 units monthly. Monthly for the 250 watts panel, we got 26 units. So just to give you explain on single month, I put here. But when we look from the whole year, average is 31 units is coming. So then second technology is floating power, which I explain as a first floating power in the country, floating power plant in the country. So we had a very good pond here. That pond was placed with the floating power, solar power. Basically, it is floated on top of Eslon pipe. This Eslon pipe all made from the Eslon, Sri Lankan company, and this fiber was made from a Norway company, but now we can make it Sri Lanka also, no problem. These are not high-end technology; these are very low-end technology. Give a lot of employment opportunity for the people. So we have all the design. The Norway company has given all the design. So this is about 6 feet depth pond, but all are floating on top of the surface. So this is how the floating solar power plant was established. At the same time, when we have the solar floating power plant, we have near to that one, we had the land-based small plant, 5 kilowatt to compare, sorry, 2.5 kilowatt to compare the power generation between the floating solar and the land-based. So accordingly, the Norway ambassador came and opened this country first, the first floating solar plant in the Kilinochchi premises of the University of Jaffna in the Sri Lanka in 2020 January. So that total power rating was 46 kilowatt. Then we have to thank for that one Professor Dalan from Norway University, who helped a lot by dedicating a lot of his time. So in average, we are getting like every month we are getting like 6,000 unit, or even I may say 5,500 unit in average every month out of the 46 kilowatt power. So these all information I have already circulated send the slides, and anybody wanted to take information, no problem at all. It's open to everybody. Then based on the floating solar also, when we calculate, okay, how much energy will be generated out of 250 watts, it's also come to about 30 units. So around 30, slightly more than that. So this was calculated in December. December, you can see earlier we put about 25, but now it's come to about 26, 26.8. So slightly higher than the rooftop solar, but you can averagely say that around 30 units is coming out from the 250 watts in Kilinochchi, Arvial Nagar area when we put the 250 watts solar panel. So let's see how the remote village school can be get benefited from this solar system. So when I just did average calculation of a computer, how much power will be taken by the computer, of course, it varies vastly depending on the technology we are using it. But in a middle range computer, will take about 300 watts of power when we look from the monitor, CPU, and the keyboard and everything together. So it will come to about 300 watts, even though 278 here is listed for the CPU, but including the monitor and everything, I have studied carefully with a few people also, I checked it. It's come to about 300 watts, so maximum 350 watts. So I take it as 300 watts. One computer is full set is taking 300 watts. So if we operate in the school little bit out of hours, then it come to 8 hours of operation. But of course, I put as a variable also. So whenever somebody wanted to change the operating hour to 4 hours, we can simply calculate using this equation. 5 days per working days they will be working. Even if they work on weekends, we can put those numbers here. Then it come almost like a 48 units per month. If I operate one computer for 8 hours per day for 5 working days, so 4 weeks become 1 month, then it's come to 48 unit consumption of power for one computer. So when we look from the, if we are connected to the CEB, where, for example, most of the town area or even the village area where the CEB connection is there, their charges are like about 18.3 rupees per unit. If it is less than 300 unit or more than 300 unit, if our total electricity consumption goes beyond 300 unit, it will come to 22.85 rupees per kilowatt hour. That means 22.85 rupees per unit. So this is the mostly commonly used tariff for the schools. But if they wanted to go beyond that on time of the day tariff, it's again come to somewhere around that range. I will not explain this to minimize the complication for the participants, but those who need, they know that the peak hour in Sri Lanka is evening 6:30 to 10:30. So that time they charge more money for unit. Day peak, that means early morning 5:30 to evening 6:30, this 21.8 rupees. O peak, which is in the dead night period, that means from 11:30 in the midnight till 5:30 in the morning, it's about 15.4 rupees. So accordingly, if it is higher than 42 kVA rating, then only they will go to the time of the day tariff. But most of the schools are below 42 kVA rating, so they may come to this kind of tariff. So minimum of 18.3 rupees or maximum of 22.85 rupees. So that is the cost. If they wanted to calculate based on one computer how much it will cost, they can go through that way. So let's see, if we have a 300 watts one computer operating for 8 hours, we will need to pay around 878 rupees per month for the one computer if you operate 8 hours. Remember that part. Some school only operate 2 hours, so they have to change the hours and calculate accordingly. That come to even the variable. If this is the power rating of the computer, I put 300 watts, 8 hours. Hours is 8. So if you put this equation, it will come to how much rupees will taken for the 1 month. If you operate one computer, but if you put two computers, we have to multiply into 2 or 3 or 4 or 5. Then basically another one is from the solar, as we already proven that from the practical measurement, one 250 watts panel will generate 30 units. So if you put one panel with 250 watts, but now the panels also vary with the power, someday in 300 watts, someday in 350 watts. So different panels are there. So depending on the panel we are using, we can put the rating and calculate accordingly how much units being generated. So and also when you put the panel, some people may ask how much roof area they need. Almost like it's like a 2 meter squared, 1 meter, 2 meter, 2 meter squared will cover about 350 to 450 watts panel. So that's the roof area. Mostly roof area will not be a limited factor. The schools will have enough roof area, but only problem is they have to have at least second story or 3-story. It will be more benefited because shadow from the tree, shadow will not come into the picture. Otherwise, shadow will be a problem for them because schools will have enormous trees. It will be good for the environment. At the same time, if we wanted to put up the solar, we need to go for like 3-story building will be much better. If we have 2-story, it will be further, it will be okay. So if I summarize the component there, if we have a 300 watts and 8 hours per day, so it come like one computer will need about 48 units within 1 month. But if I have 250 watts solar panel, that will generate 30 units per month. So accordingly, if I just prepare a table where maybe I may use one computer for 8 hours or one computer for 4 hours per day, only weekdays, or 5 computers for 4 hours or 10 computers for 4 hours. For example, if I use 10 computers for 4 hours, then 240 units per month. To capture this 240 units per month, one 250 watts panel will create 30 units. So 8 250 watts panel will be enough. That means 2 kilowatt rated panel will be enough to support 10 computers in the installed in the school. So accordingly, so now you know that if we have 10 computers which are operating average of 4 hours per day, then we can install with 8 panel with 250 watts. So total rating of 2 kilowatts. That means 2000 watts panel, maybe combination of 400 watts or 300 watts or 250 watts, whatever the combination available in the market for the economical purpose. So now let's see, to do this one, there are 2 ways. One way is if the school is far away from the CB connection point. For example, if the CB line is coming closer to the school, it will better to go with the grid connected system. That means CB grid is there. So they can go with the net metering or net plus. So they can talk to the area engineer and arrange the discussion with them, area engineer of the CB, where our engineer Amalendran also will talk during the discussion time on that one. So they can go with the CB net metering or net plus arrangement and install the solar in the rooftop, and they can make the agreement and process that one. If they are closer to the CB connection line. But if they are far away from the CB connection line, somewhere around in the Langaville or somewhere very very distant area, then they may need some islanded operation. That means not connected to the CEB. It is a separately operation. Then they need the support of the battery. The most wherever grid is not available, then they have to go with the battery. If there's a grid available, better to go without the battery, which will be cheaper in terms of life cycle analysis. That means whenever you put the battery, you may have a problem with the battery, because battery will get into the uh, uh, trouble after some time, because battery lifetime will be sometime 2 years, 3 years, 4 years, depending on the quality of the battery. But if you go for the 4 years battery lifetime, then you may go with some high quality battery. Then the cost will be, initial cost will be very high. When you go with the cheapest cost, then the battery will need to be replaced after 2 years or 3 years. So that battery will create some problem. Still, battery technology is heavily on research, and it's developed a lot, but still more to develop. So in the future, battery will come more and more cheaper, high quality batteries. But if we can avoid the battery, it will be better. So that is why we are saying, if you feel there's a grid very closer to you, go with the grid connection. If it is unavailable, then go with the battery. That is the only option for that one. So that is two type of connection with the solar to the grid, solar to the school. So let's see. Now we are going to go with the 10 computer school. Maybe 4 hours per day they are using it, 5 days per week. So they ended up with the 250 watts panel or 2 kilowatt system. So for this computer, but of course, anything vary, you can easily change the numbers and calculate, because the calculation equation also given. So this need 2 kilowatt system. So whenever we look from the 2 kilowatt islanded operation, because our focus today is mainly to the very rural area schools. But of course, other one is a grid connection that is already explained. So if you go for the islanded operation, I just check the price component is vary between 500,000 to 600,000. So this component, of course, I am sure that Mr. Ramesh is here, who is a very well successful entrepreneur in Northern Province on solar PV installation, and a lot of work they have done it. So he will be telling more on this site about the cost and the installation part in the discussion time. But from my presentation, just to give you a brief idea on that, it will cost about 5 lakhs to 6 lakhs if you're going to go to install 2 kilowatt system with the battery. So again, battery cost will be determined by the quality of the battery, and you may need to replace after some time. So those things you have to concern. So that is also written at the second paragraph. So that is a determined factor for the cost as well. So sometimes it may go to 500 or 600. So we have to optimize what type of battery we are going to use it and things like that. So that is that give you very overall information about this. But if I tell you the rooftop solar, which is going to grid connected, some component I will explain here. You will be installing the PV there, whether rooftop or islanded operation. Definitely it will be happen both condition. Then inverter will be needed for both condition. You may need inverters to convert from the solar power DC to the AC. Then the bulb will be connected. If you have grid, this grid connection will come. Otherwise, this component will added with the battery, and here it will be disconnected. So it will be islanded operation. Only this much is enough. But net meter will come. If you have grid, you will connect the grid here. Instead of the grid, you may connect the battery if you don't have a grid. That is a two system. One is with the grid, other one is without the grid, and put the battery here. So that is battery at this point. So that will give you the two different, whatever the two different system, PV, this inverter, and your electric service panel. This is for your, already you have the house wiring panels there. So this will be connected to that panel. So if you have grid will be coming here. If you don't have grid, battery will be connected there. That's only two different between two systems. So during the discussion, I am sure Chief Engineer Mr. Amalendran, who is from the northern province, North CEB, Children Electricity Board. He will be help us to talk about grid connectivity and any other related issues. If you are going to grid connection or off grid connection, he will tell from the electrical engineer point of view. And also we have a very successful entrepreneur, Mr. Ramesh, in this forum. He will talk about the PV installation and costing in accurate during the discussion. So if I take you one more step, which is I don't want to explain more in this forum as it is covering all common people. But if I tell you, we are, of course, this research is already going on mini DC grid. If your target is only computers and the lights in the school, we can also implement the DC microgrid system. What is mean by DC microgrid system is, for example, now the solar PV generating DC, and we are converting to AC and give it to the normal bulbs and kettle and radio, TV, everything we are giving because solar operating with the AC system, alternative current system. But if you take the computer is operating with the DC. Actually, you are giving the AC supply to the computer and then again convert back to the DC and convert the computer is using it. And also bulb can be used directly with the DC as well. So rather having DC, converting to AC here and again go to the computer and convert the AC back to DC and give it to the computer, we can directly transfer DC to DC. So that is what I have listed in the last slide, which is a little bit of taking you towards the research and development and the future possibilities. If you find that the school is very far away and next 10 years it will never get the grid connection, if we confidently feel that is that is going to be happen like 10 years, the grid will never come closer to us, then it is even 10 or 5 years, then it is worth to invest the islanded operation. That means without grid connection, with the battery, we can go with the solar powered to the computer as well as the batteries, as well as the lights. But in case if the university want any high-end contribution from our brain, we can also help with Ramesh. I will discuss with him. We can put up directly DC to DC without going through the DC AC, AC DC conversion. So that is one possible. I'm just listing here. Because that will minimize the cost as well as even damages as well as. So with that one, I am almost done the presentation, take you through some motivational talk on solar PV and the wind, especially on renewable energy technologies, because it's going to create big business to the northern province. So my focus on this talk in both directions, while we are supporting the rural area schools, at the same time, why don't we little bit motivate on other side on entrepreneurship and business development to the rural area village people as well. They can come up with the starting with the electricians and finally come up with the engineers or entrepreneurs. They can go beyond that one. Then second one is anybody wanted to learn more in depth, always welcome to Faculty of Engineering. We are open, working almost like day and night. Even if I have so much of slides to show you if you want, but that will take enormous time, but it will divert our focus as well. But you are always welcome and talk to us. We can take you into the system and show you how it's work and how we design and everything. Then the third one is definitely for the rural area schools. We can work together with even today discussion. There are enough people like chief engineer, CB and entrepreneur, Mr. Ramesh and myself is here. So we can answer almost any question you come across. So with that one, I am concluding my talk and we'll be pleased to start the discussion. Thank you so much.